All right, everybody, we're going to talk about trig proofs today. First things first, daily quiz today. You have a my math lab due on Sunday, and there's a new my math lab due next Thursday. I'm going to come back here to the top at the end, but I also want to remind you that it's okay. We have been working up to doing trig proofs, so please don't be freaked out by this. In the past couple of classes, when we simplified, which was way back at school, and now, when we started, or the other class, when we started solving equations, you have been working up to doing trig proofs. So please don't get worried or stressed out because you can do this. Okay, so here are some suggestions when you're doing your trig proofs. Number one, start from one side of the equation. Take the left or the right, but not both, one or the other. Go through and try to manipulate that side, add, subtract, multiply, divide, use commutative property, etc. Do substitution, combine your terms, combine your fractions, multiply by your conjugate or factor, all things you did when you solved equations, and try to end up with the equation on the other side. One other thing that I would suggest when you're working on proofs is try not to do any work off to the side because then you're going to skip steps. So make sure that you do all your work in your proof. If you can't get there, then go back and redo that step. Okay? Or maybe start over. Sometimes it's a little guess and check. I'm going to walk you through a couple of proofs, and then there's a whole bunch of practice at the bottom for you to work on. So here's my first example. And let me try to shrink it so it goes in. There we go. So tangent x plus cotangent x equals secant times cosecant. So the first thing I went ahead and did was change my cotangents to sine and cosine. And why did I do that? Because if you think about it, secant and cosecant are really reciprocal functions of sine and cosine. So if I don't have things in terms of sine and cosine, there's no way to get to secant and cosecant. So I changed everything to sine plus cosine. Then I cannot add like fractions unless they have common denominators. They do not have common denominators, so I need to get common denominators. And the common denominator here would be sine x cosine x. So I'm going to multiply by those fractions to get sine x cosine x in the denominator. I got to multiply my numerators, and that gives me sine squared cosine squared. Then I can add my fractions. So I take the numerator plus the numerator. Remember, leave the denominators alone. And that gives me this term, which is great because sine x or sine squared plus cosine squared equals 1. So I can replace that. Then I can pull that back apart into two different fractions, which are reciprocal functions. That gives me my cosecant and my secant. And then you can switch the order of that because it's multiplication. So that's commutative property. So there's example number 1. Now, example number 2 looks a lot longer, but really that's because I tried to write out every single step so you could see exactly what was going on. So again, the first thing I did with my left side, so I started on the left, I had two fractions. Well, I can't add two fractions unless I have common denominators. So I went ahead and multiplied by each of the other denominators so that I got secant x plus 1 and secant x minus 1 in the denominator. Now, when you multiply secant x plus 1 and secant x minus 1, I have the same two terms, 1 plus 1 minus. So that's that a squared plus b squared, or a squared minus b squared situation. So that turns into secant squared x minus 1 squared, but we all know 1 squared is really 1. So in the denominator, you're going to see secant squared x minus 1, and that's because I did a plus b times a minus b. That gives me a squared minus b squared. In the numerator, then I can go ahead and add those two things together. So secant x plus 1, secant x minus 1, the 1's cancel out because I have 1 plus and 1 minus. And secant x plus secant x gives me 2 secant x's. That's great, except now I need to get rid of some of the 1's in the denominator. So I used my Pythagorean identity where secant squared equaled 1 plus tangent. And when I did that, then my 1's will cancel out. separate that out, and I get secant x, 2 secant x over 1 tangent squared. So then I changed 1 over tangent to cotangent squared. So that's my reciprocal function. I took my squared and separated it into that thing times itself. That's basically what squared means. Take anything times itself. So cotangent squared becomes cotangent times cotangent. And then I went through and wrote the reciprocal functions for the secant and the first cotangent so that I could get the cosines to go away. So now I have 2, 1 over sine, and 1 cotangent. 1 over sine is cosecant, and then again, commutative property to put that in the right order, like the number at the bottom. All right, equation 3 is much shorter, or example 3. So the first thing I did one more time was multiply by the conjugate so that I got that a plus b times a minus b is a squared minus b squared value in that second line. And then I also distributed the, didn't distribute, sorry, I multiplied but did not distribute that top part. I did write the cosine first. The reason I did that is because then I'm going to substitute 1 minus sine squared in for cosine squared. And that way I can cancel out one of the cosines from the numerator and one of the cosines from the denominator, and then I get the right side. So then final problem is pretty short too. First thing I'm going to do is use my Pythagorean identity to replace that cotangent with a cosecant because there's cosecants in the denominator and where I'm trying to go. So I replace that cotangent with cosecant minus 1. And then again, that's that a squared minus b squared value. So I factor that into a plus b, a minus b. So cosecant plus 1, cosecant minus 1. Then cosecant plus 1 and 1 plus cosecant are the same thing because addition is commutative. So I can cross out the cosecants plus 1s. There's 1 in the numerator, 1 in the denominator. And that gives me what I'm looking for, which is cosecant minus 1. I suggest you go through and you replay those too. I think that will help a little bit. And let me know if you have questions during office hours today. There is a whole bunch of practice, and at the bottom of the practice is the answers with how they got those things. So as you're working, if you get confused, you can go down there and kind of look, and then feel free to ask questions on those during office hours too. All right, so once you go through and work out all of your practice, one of the things I'd like you to do is see if you can get onto this Edulastic assignment and do the one question proofs quiz. It's a reordering question, so all the steps are there. You just got to put them in order. And I'm really trying to see how well this Edulastic software works. You're going to need to click the link, try to log in with your Microsoft ID. That's your computer ID and your computer password. Or sorry, your school email and your computer password. And then you might have to join our pre-calc class. I'm not exactly sure what the next couple of steps look like, but you may have to join our pre-calc class and then try to get to the assignment. If you have questions, let me know. I'd like to take this for a grade, but if it gets really, really crazy and awful, then we can start exempting you. But I would really like to try to use this software. So if you could test it out for me and see if you can get to that one question quiz. That would be great. All right, email me at office hours if you have questions. Thanks.